Now we can estimate the population mean. So please look at the formula. First of all, here's the yi bar, which was the average. In the selected, it's a cluster I in the sample. So for example, it is an average income from the sample. And the next one, here's the MI, the big MI. Actually it was the new notation. It's the total number of elements. So which was the total is a number of elements in the cluster I. Simply I can say it is a total number of people in the cluster I. And now here's take the summation. Yep, let's look at this one. Is that there's a small n. So that means it is the summation of the multiplication in the sample and then divided by n. So now it's actually the ratio. It is an average. It is an average. The average of the income, right? And we adjusted with the as number of people, right? And now we multiply another ratio. The big N was the number of clusters, the total. Okay, just a second. The total is a number of clusters in the population. So now we multiply the n, so we can expand to the population, and the big M was the it was the summation of the big MI is in the population, so which was the total number of elements, people in the population. So now I can interpret the second part. The second part was the that is a ratio from the sample, and we expand it's up to the population. So it is the estimated the population mean. That's good, right? And this one is a nothing. It just the flipped ratio, because the big M was defined is a big M over big N. So simply we just flipped the first fraction. Yep, so that is the same thing. So let me erase everything. So please try to understand how can we estimate the population mean by the two-stage cluster sampling. Okay, and the second one is the estimated variance. Actually it has two terms. It is the first one, and this one is the second one. Simply I can say the first one, it is the variation in the stage 1. So from the population, when we take the clusters, it's a sum of them. Yep, this much. We have the variation. And the second one, it is another additional variation. It is an additional variance in stage number 2. When we select some elements, right? So we have as many elements in the cluster. We didn't select all of them, so we did some of them. So we are going to have this much, the additional variation from the second stage number 2, from the second stage. So we have 2 parts. The first one from the stage number 1 when we are selecting the clusters, and the second one, it can be raised from the second stage when we are selecting some elements from the selected clusters, from the selected clusters. So here's a SB square here, like this way, and here's a SI square here, it's like this way. So when you look at the formula, here's a I. So that means it is from, it's a cluster, and this one from the population. Stage number 1 in stage is number 1, and in the stage is number 2. Okay, so yeah, it is a similar as the variance when we discussed in chapter 8. Yeah, because it is raised from the stage number 1 when we select the sum clusters, and this one is the additional one. So we have the 2 estimation. One is for the mean and the other one is for the variance. And now here's another estimation for the population total, and this one is the estimated variance of the total. So simply, it's at the beginning there is the m and m square. Again, the m was summation of the big MIs in the population. So actually it was the estimation for the population mean, the estimated population mean, and this one is the estimated variance for the estimated population mean. So simply we just multiply how many clusters. Yeah, so the big M was the total, it's a number of clusters in the population. Yeah, so it is very simple. So it's almost the same as the estimation for the mean. So please make the pair with the mean and with the total. It's almost the same thing.